you can see why you've all been grouped together, similar types of challenges and projects. So it's kind of neat that you guys can share the experience together today. Again, we'll go through Wausau, and then we'll have some time where we can, it's actually, kind of fun. I saw a group standing around talking about sharing stories and things, and we'll have some time for that. And we can have some open discussion in here. It'd actually be nice for, the visitors to hear some of those stories, because those aren't always the things that you hear when your kids are off at school working on these things and the project's going on. You just kind of, I don't even know what the kids talk to you. So we're going to make sure that you get some shared stories today, and that you get to experience a little bit of it too. And also we have, don't forget, we have Excite teachers here that are trying to put together grant applications so that their kids can become InvenTeams just like you guys next year. So they've been working real hard, racking their brains on, how are we going to do this? How are we going to get this together? So I'm sure they'll have some questions for you as well. So we're going to open up right now to Wausau West High School out of Wausau, Wisconsin, and you guys take it away.
Good morning. We'll start off by introducing ourselves up on the floor here. My name is Ethan Klein.
Brandon Muller.
And like you said, we're from Wausau West High School in Wausau, Wisconsin. I'll tell you a little bit about our team here. Our teacher, Mr. Pearson, standing in the back with the camera. And then we got a 12-member team, 9 of which are here at MIT to show off our projects. This location for our school, obviously you guys all know the U.S., Wisconsin, and then Wausau is right in the center of Wisconsin, and Wausau West High School is right here. We were all out of our Wausau, the technology department in Wausau West, which is right in the north end of the building. Just some facts about Wausau too. Wausau has a population of about 40,000, so not a huge city, but it has a little bit larger metropolitan area, and it's basically a big compilation of several communities in the area. Our school is about 1,400 students, and we're one of 3 schools within Wausau. And then in Wausau, we had a record snowfall this year of 84 inches, with 58 being the average in the last 40 years. And Boston has about 53 inches a year, so kind of have a comparison. We're pretty similar. So, yeah. A little bit about the project history. This all began basically last year in Project Lead the Way, which is an engineering curriculum that's offered at schools across the nation. Engineering Design Development is the name of the class that we were all in, and that's basically the capstone course. And so for that course, basically what happens, you have 2 or 3-person teams, and those teams find a problem that they have in daily life, and they spend the year working on solutions, and they get a very small budget, much smaller than what you get with MIT. And you basically are reliant on working with some area companies to develop your project and kind of come to a solution by the end of the year. For that project, 2 of the members that are here today, Brendan and Jimmy, had worked on the original model of this prototype that Brendan will be talking about later. And also with that one, we had daily scheduled class time as opposed to a little bit situation that we'll talk about later. Kind of the reason that we did this project. Originally they had looked at snow. Obviously snow removal is a big issue for a lot of people in the U.S. 55% of the U.S. has over 15 or more inches of snow. And so for Wisconsin, like we said, we have 58 inches. So as we're moving snow, we get tired of it. We don't want to shovel. And snow removal can get costly with gas and is also very dangerous. So you can see above, we have over 11,000 injuries and over 100 deaths just in the U.S. alone from snow removal. So our goal is basically to create something that would either eliminate or at least reduce the injuries and deaths associated with snow removal.
So when we started this project this year, carrying over from last year, we had 3 main things that we wanted to kind of solve. There's our battery runtime. We wanted to be able to run for at least 1 hour. The auger, what you could remove with a snowblower, we wanted to have 3 inches. And you wanted to be able to throw that 15 feet over your snowbank, whatever you may have there. And then also we wanted to have this be semi-autonomous, so that what you could have, you could send it out during any type of snowstorm. And what we want to have with that is so that it wouldn't deviate off of the path more than 6 inches. Kind of talk to you guys about last year's project that I was also a part of. It was a simple project, and what we had was wheelchairs that were donated from Spires Home Medical Care in Wausau. And what we did is we stripped that all the way down to the base frame with 2 batteries and then the drive motors. And on the front of that, what we put on there was a custom frame, or a custom plow, that was donated from Green Neck Fan Corporation in Wausau as well. As you can see here, we had a fixed plow, and the problems we kind of ran into here is if you're working on an uneven surface with that fixed plow like that, you can't plow the snow properly, you can't really push the snow around the way that you want to. And that was the initial prototype. With that, we had simple servo motors, and there was no variable speed on that. Then carrying over to this year, once we received word that we had the grant, what we wanted to do was break down the initial prototypes into different areas. The first area we worked on was the navigation prototype. And what you see up here is one of the first initial ideas, and using Flex Robotics hardware and then Robot C programming, what we wanted to do is kind of see the different options that we had for the semi-autonomous operation of our robot. And with this, it was a simple line follower. And what we found over the test that we did was that it was going to take a lot to modify your driveway, whether it be a magnetic strip that was under your driveway, that was obviously not feasible. And then the other option was having a line, colored line on your driveway. If you have snow on the ground, that robot's obviously not going to see it. And then what we wanted to do is, so we had the navigation, we worked with that prototype, and then we looked at the drive prototype to see if the motors that we had from the wheelchairs from last year, using those, we wanted to see if it was feasible to use those motors on this project. So we had a custom frame that was built in-house. We took the motors off of those wheelchairs, we put that on the frame here. And as you can see here, it moves around relatively easy. And on this one, we had variable speed on here, so this allowed us to control it easier. As you can see there, there was better fluid movement around. And on this prototype, we didn't have autonomous operation on this one. That's what we kind of worked towards the end. Now here is kind of where we brought everything together. Took a 1970s snowblower that was donated from Freeview, and with that snowblower, we took the front half of it, and we put it on the frame that you saw in the previous video. And what we did is, this is when we were able to first test the RC control on that. We don't have the autonomous portion on there yet. And what we were able to see is that this concept would work. You'd be able to use all electric, and you could use this snowblower. That we did, there was 3 points of contact on that snowblower. What we found is that when you went over whenever you went over a curb, or as you drove into the snowbank, what would happen is the plow, as you're going into the snowbank, it would raise up, and those drive motors that were right in the middle, there wouldn't be contact with the ground, and because of that, you'd lose traction and you couldn't move off of the snowbank. You'd have to pull it off by hand. That defeats the purpose of what we're trying to do. And then what we wanted to do with that second prototype, we wanted to make some modifications. And that's what we did here. I'll kind of show you before we do the video here. If you look here on the back side, we have a larger trail wheel. And with that trail wheel, so it's able to spin in the snow a little bit better than the previous trail wheel that we had. You couldn't see that one on the previous prototype. And then the second major change that we made, you can't see it in here, it's behind the wheel. But what we allowed to do was this snowblower is allowed to pivot up and down. So as it goes into the snowbank, the snowblower is allowed to move up and down. And then you can back off the snowblower, spin around, and continue what you're doing. And then what we found over time was this frame that we initially designed wasn't designed to hold the weight that we were asking it to do. So then what we wanted to do with the final prototype that we have with this now, we wanted to make it much smaller and compact unit that was easier to operate. Everything was in a smaller area. The electronics are in one area, so you can get at those easier. And this custom frame that you see in the video here was designed in-house, and then we used help from engineers at EurekaFest Corporation in Wausau, Wisconsin. With their help, we were able to design this frame, and with this, it's a simple design. Everything kind of it's modular, so everything comes apart, cover comes off, and then there's a frame inside that holds the 2 batteries that were also purchased, 24-volt battery packs inside. And then we also had a 24-inch blower unit that was donated from the Aaron's Blower Company in Berlin, Wisconsin. And with this, with everything being smaller and compact, it was better weight distribution. We had obviously better traction, and There's a much better prototype that we could see, much smaller, compact, easier to work with. The limitation that we had on this one, this is when we first put our autonomous portion into the snowblower. There's inconsistent playback of the recording that we had, and Noah will take it up and he can talk about that more.
Yeah, so I'm going to talk a little bit more about the technical side of the project. And when people think about navigation, most commonly the thing that comes to mind is GPS. That's what we tried to do for the better half of the year, was to try and program it to use GPS waypoints and just try and go to the next waypoint, and that's how it got to its path. But later in the year, we went out and visited a guy named Terry Anderson in Minnesota, and he's part of the Autonomous Tractor Corporation, and he showed us path learning. And what that is you essentially teach the snowplow, or the snowblower rather, the path that you want it to do. So you drive it out with RC first, it remembers all the RC inputs, and then when you want to play back the path later, it'll play it back autonomously. So a brief look into how this works is the RC transmitter sends its signals over the air to the RC receiver, which it then relays that to the autonomy controller. The autonomy controller, which is an Arduino microcontroller, saves these RC inputs onto an SD card. And then later, when you want to play back the path to have it be autonomous, the Arduino reads it off the SD card and sends those RC values into the motor controller as if it was coming from the transmitter itself. So just giving you a brief look at our setup here. This is all of our wiring that makes this all possible. And we mounted everything vertically on either side of the interior of the snowblower. And on the right side, we have the motor controllers and all the main power. And on the left side, we have all the autonomy controls. And here's just a schematic that shows that. And I just want to point a few things out. Right there is the Arduino microcontroller. It gets the inputs from the RC receiver and saves them to the SD card over here. And then later, it will output those out to the motors. All right. I'm going to hand it off to you.
So I'm going to talk a little bit about how we organize all of our work throughout the year. At Wausau West, we have a special schedule. It's called the FlexMod schedule. So basically, each day there's 21 15-minute mods with a 5-minute pacing time. So a 2-mod class would be 35 minutes long, a 3-mod class would be 55 minutes long. And so each week we had from 9 to 9:55 on Mondays, we had scheduled class time. And then in our schedule we have unstructured time, which you can see in the blue. And that's where we don't have class scheduled, we can go get help with anything we need. Well, for us that was time to work on our project. And so most of this project was done outside of class, also on weekends and school nights. As far as our finances, we had $8,000 towards our grant, and we found it pretty easy to spend money. But not only just spending the money, just having the Lemelson-MIT program name, we found helped us receive more donations throughout the year. We estimate that we have over $10,000 of donated goods throughout the entire year, as well as in money. We had a crowdfunding set up to help us travel, and we found that was a good way to help us get out here to Boston. As far as our communications, we had a Facebook, a Twitter, and a website. So we had our blog set up, we updated pretty regularly, and with that, those would automatically go on Facebook and Twitter. People could follow throughout the year what we were doing. Local area news was in, the Associated Press picked up the story, and it was actually aired down in Florida, and we received some help from someone down there. They sent us a letter and sent us some drawings of the project that they had done with the snowblower from down there. So with that, I'll turn it over to Ethan about our presentations and travel.
Throughout the year, not only did we submit to the required mid-grant technical review, we also were participating in quite a few other presentations as well as quite a bit of travel. One of the biggest presentations that we did was at the mid-grant technical review. You can see the numbers there indicate just approximately how many people were at that presentation. With that one, we had not only our project, but our department working there. And we were able to have all of the students there and have all of our supporters and coordinators working with us, and then we also had several elected officials from the area and the state that were present. We also attended several events or areas where we went and got to learn about our project or more things about our project from other companies. One of our most influential trips, or one of the two most influential trips, was our Arians trip. So if you're familiar with the Arians company, they're in Burlington, Wisconsin, and they're a snowblower and lawnmower company that are based in Wisconsin. And as you can see on our original blower, that model was the 70s snowblower that was featured that we donated from a hardware store in Wausau. And also on the final prototype was actually a brand new model donated from Arians. And then also we would visit Autonomous Tractor Corporation, like Noah talked about. He was out there out in St. Michael, Minnesota, and he helped us a lot with the autonomous portion of the project. Some of the next steps of kind of the technical side of things that we hope to cover. We want to have a pulley cover basically for safety reasons. Right now the pulley is exposed, so if you were to get your finger stuck in there, that could cause some serious problems. We also want to work on a shoe flap actuator and shoe control. So right now we have a stepper motor that's mounted, and soon we'll be programming it to be able to control which direction the shoe's facing. And at some point we'd like to incorporate something, like I said, to control whether the chute is fully up or fully down or anywhere in between. We also want to incorporate some safety and lighting systems, so in case you're, like this would be basically operating your driveway. If you were to leave a car or your snowboard or anything else laying out in the driveway, it wouldn't get run over and chopped by the snowblower. And also if a person or a child were to run in front of it, they wouldn't get injured by the snowblower as well. Along with that, we also hope to integrate a user interface, because this would really clearly be a product that a customer, any general customer would be able to use. And we want to be able to be something that they could just press a button, or be able to just have a screen or similar to something on your phone where you say the power and some other facts about the trip that's working on right now. We also have some feature team advice. One of our biggest things and our biggest limitations was the underclassmen involved in the diversity of our team. We had all seniors except for one. Mitchell was a sophomore, and then we also basically had a lot of engineering minds in our project. So as well as that was very helpful for working along on the technical side of the project, it would have been more advantageous to us to incorporate people who are good in the marketing department, are good in communication, and will help with communications, and also have someone to work on finances who is more specified in the area of handling money and coordinating things like money planning and other sides of our project. We also, along with money, was fast shipping. We had a lot of electrical components, and as many of you guys found out, that they take quite a while to ship, usually from the companies. And so that would be one of the things we advise if you're working on any kind of componentry, to plan for fast shipping, because like the Alaska team found out, it can be quite a hindrance to have things shipped at a delayed time. So if you can get things there immediately, it's going to save a lot of time on your project and not set you back. One of our greatest assets and features was engaging our community. We had some of the biggest support in not only our city, but our state and out of our state, like I said, in Minnesota. We had quite a few supporters all around the area, and none of this project would have been possible. Like Jimmy said, we had just over $10,000 valued in goods and services donated from people and businesses in the area, and the entire project would have been possible without their help. I'd like to thank all those guys, and Mr. Peterson and MIT for making all this possible for us.
Open the floor up for question and answer.
With the learning system automation, if there's an obstacle in the way, let's say there's just hypothetically a stone, a big stone in the way that's now wasn't there before, and the tractor, the snowblower can't go through it. How does the system go around that, or how does that work?
At this point, we haven't incorporated any safety features into it or any sort of sensing that would know that that would be there. But that's something that we're looking to incorporate in the future. And what would happen is, instead of going around it, we just probably interrupt the playback of the RC inputs and just have it sit where it is and give a notification to the owner, like on a smartphone or something.
Go ahead.
Hold up. What kind of sensors are you looking at?
Sonar sensors and IR sensors.
With your pathway tracking, you had to start in the same spot every time. How did you determine that with snow on the ground and other things in the way?
Yeah, You record it in one place and it can be played back anywhere, so it can be played back in someone else's driveway. So it's relative location, not absolute location. So, yeah.
Yeah, essentially you had to put it back in the same spot, and something that we had looked at, as I'm sure many of you guys found out, you had these great plans at the beginning of the project that you wanted everything to happen perfectly, and along the way you find some things that are hindering you, and one of the things that we had found, we had planned on doing and would like to see in the future still is having a docking station, so basically have a little box that it'll drive up to, park itself in, like you guys had talked about, be able to recharge and things like that. We'd have it recharge the battery system. Right now it has a 24-volt system on there and it has 2 big battery stacks. So it lasts roughly an hour of service time. So just about enough time to do an average sized driveway, in a normal residential neighborhood. But like you said, it would park into the same location each time, so you wouldn't have to worry about it moving, being in a different spot and starting the same course and being at different places.
I don't know if it was ever a plan on being incorporated in your guys' project or thought of, would you ever think about like, I don't know if we do get bucks going for like solar kind of deal?
Yeah, we had thought about that. We had thought about a lot of different ways of doing renewable energy. Kind of, we had, like I said, at the beginning of the project, we had thought a lot of these things through. And I guess we had definitely thought about solar. As you kind of brought up, snow can be an issue with the, snow staying on top of the solar collector. And, you could see it where that would run into an issue. And at the time, I guess we're kind of just thinking right now, you plug it into the house, and then on top of your house or something like that, you could have your solar panels located. But we did originally think, doing a solar panel located on top of the box unit I was talking about.
Did you have any problem with temperature hindering your battery supply or running in the colder temperatures?
Yeah, colder temperatures do affect the battery life negatively. So we probably could have gotten more out of them if we were in a warmer climate, but it wasn't a huge problem for us because we had fairly big batteries, so we still got an hour runtime, as Ethan said.
Essentially, I was going to add some of that. Essentially, we were using car batteries. They were from the 2 original batteries were from the wheelchair base, and that one had 2 batteries in it. And then as we went into our first drive prototype, we had 2 batteries. But then once we expanded into the second prototype, we had two 24-volt stacks added, and together. And from that, right now it's not. I don't know exactly how many batteries are in it, but it's a pretty comparable amount of battery life. Once we add the second battery stack, it.
Well, you're talking about the detail on the batteries exactly. The batteries that we have now, there's 2 battery packs, and there's 6 batteries in each of those, and it's comparable to batteries that we had previously, but there's a longer battery life. The reason being is those batteries actually we purchased those from the company that made the batteries for the Aaron Snowblower Company. They had an electric snowblower on the market several years back. They pull it off the market for certain reasons, and we contacted that company that had those batteries, and we had them make 2 batteries for us, and then we purchased those from them. So those batteries are comparable to what Aaron's had on their snowblowers in a similar condition than we're going to have.
So can you just map out what exactly the type of your battery is?
It's lead acid generators.
Oh, right. One thing, just from our experiences in drones, from what we understand, the best weight to power ratio is LiPo, so if you guys want to look at that, it might be.
Yeah, and essentially for our situation, almost more weight is better. Because we want, traction, and we have 16-inch tires on it right now. It originally started with 8 inches, and we went to 12, and now we're at 16, which we're also donating from Arians. We kind of figure out that more weight's better. Our unit weighs approximately 250 pounds, somewhere around there right now. The batteries are 100 pounds. The 2 batteries are 50 pounds a piece, and then it's a 1/4-inch sheet metal base and it's an 1/8-inch sheet metal frame. So yeah, go ahead.
Actually, when you were deciding how to set the battery configuration, what was your limiting factor? What were your design constraints?
As far as like the placement of where we put batteries,
Yeah.
the thing that we wanted to do when we made that box, like I was.
Oh yeah.
Yeah, this is good here. I can kind of give you an explanation of everything total. So this is kind of looking from the back, and as you see the batteries here, what we wanted to do was, and then this is the auger this is the drive motor for the snowblower itself. And what we wanted to do when we decided this we wanted to keep everything in one area. So we have all the electronics up top. And what we wanted to do is keep the weight. So we put 100, obviously these batteries being 100 pounds, we wanted to get the weight as low as possible. So we had that traction. And our limiting factor was we wanted to keep it as small as possible. So the height of these batteries is like 8 inches, 7.8 inches, I think. And that was our limiting factor. We put them in vertically, and then that was kind of the design where we came from that.
And also, like you said, we kept all the way at the bottom. This is the 1/4-inch sheet metal base, and these are all 1/8 inch. So this is the heaviest frame piece. Each of these are the gearboxes. The motors are behind them. Each of those weighs about 20 pounds, I believe. And then, like I said, the batteries are 100. So basically, all the weight is right on the bottom, right along the axis of where the wheels are. And then this thing weighs roughly, I think, 40 pounds. And then the frame is all the extra, and then they just electrical components, and the snowblower actually in the front probably weighs about 50 pounds.
How long do you charge the battery?
The battery charging, we haven't from,
It's probably roughly around 4 or 5 hours from a dead to full charge, I'm guessing. We usually do it overnight, but I just know from experience of charging those types of batteries, it's probably about 4 to 5 hours. And we have a smart charger for it, so it just, it's all wired into the system here. You can see there's always, someone has bundled cables right here. There's basically that plugs into our charger. So now the system is all disconnected by a key on the side here. So at any time you can just turn off the power key, and then that disrupts it from connecting with the board. So if you were to plug into the wall, it wouldn't overcharge, run too much power through the boards. So it can just charge the batteries at any time with just a simple plug-in on the cable. And that was one of the things as we were getting close to this date. We kind of, like I said, we finalized all this, compacted all of it, made it really small, and then we were looking at these finite details, things we could, kind of to clean it up and make it more efficient, in the time period that we had of a couple of weeks at the end here. And so one of the things we realized we can just make all this wiring as simple as possible. And it looks a little bit of a jumble right here. It's actually a lot more compact. If you guys come and check out the model at our stand, we can pull this all apart for you. It's all sitting there. And like I said, it's just a cable that pops out and you just plug it in to charge it. So it's essentially all you need to do to interact with the piece from the exterior is the key and then the power cable.
Does it drive different at different battery voltages?
It slows down. The RC control relays how much voltage it's supposed to supply to the motors. I'm trying to think. We just had when we shipped it here, we actually just charged it overnight because during shipping. I must have been the shaking or something. The batteries got down from, we had them almost fully charged when we left, and they were at about 25% when we got here. So, and we never seen, they last, we do it, 25-minute testing or something like that, and they last for, days and days and days you can work on them. So I must have spent something with all the shipping and bouncing around, they got weakened a little bit. But it definitely slows down. I don't think we've really done any autonomous tests yet, low power.
Everything was a little tight as far as.
We didn't really get the autonomous part until the snow was gone in Wisconsin, which was we had all of basically what you guys kind of have in pages how it worked out for us. All the mechanical portion, like the snowboard and all that, we all had figured out while the snow was here, and you saw we had the video of the snow. And so we didn't really realize at the time, but looking at it back now, it worked out fairly smoothly as far as having all the things that matter to be in the snow there, because you don't really need snow to have test out the path. More of just you can test the path there, and you can say, okay, it's going to work in snow either way.
question over here.
Is from the motors to the wheels, what's the power transmission system there? Is there a direct drive or is there a gear train?
They are electric motors, so.
They have a gearbox.
Yeah, they have a gearbox and that gears them down a little bit to get more torque.
The gray pieces right there, the gearboxes that you see, the motors, you can't see any of the
Right angle.
They're
Motor.
independently driven too, so
That-
that side is by itself.
That black piece with the warrior head, you can only see it, that's our school logo, is right behind the wheels, and that's where you see it. And you'll see it on our model, it's all tucked in really smoothly into our final prototype. And like Brandon said, efficiency was kind of the goal of this final piece, get as close as possible. And something else you don't see in this picture is there's an EM shield that's, there's an EM shield that was, that goes around the blue motor, the drive motor, to protect for the electrical componentry to work with GPS.
Any other questions?
Yeah, feel free to visit us at our stand too. We have it all there so we can pull it all apart if you want to look at exactly how the wiring works or just kind of see how it's all laid out.